Day 321 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 704, binary search. The difficulty level is easy, so you already know we're going to keep the solution. Y'all, we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now, let's see what the question says. Given an array integers nums, which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. You must write an algorithm with big O, log n runtime complexity. All right, y'all, sounds simple enough, but let's go ahead and take a look at these examples just to make sure we're doing this problem correctly. So in example 1, we have the input nums equals an array of integers -1, 0, 3, 5, 9, and 12. Target equals 9. The output is 4. Explanation says 9 exists in nums and its index is 9. So all they want us to do is search through this array and find the target. Boom. And then when we find the target, return its index. So in this case, the target is 9. It's at index. So we start from index 0. We go index 0, index 1, index 2, index 3, index 4. So 9 is at index 4. So that's why we're going to return 4, because that's the index of the target. So let's go ahead and take a look at example 2. It's pretty similar. It's the same principle, but let's go through it anyway. So, well, actually, it's not the same. It's a little different because in this case, the target doesn't exist. So we have to return -1. Boom. So in example 2, we have the input nums equals an array of integers -1, 0, 3, 5, 9, and 12. This time the target is 2. So as you can see, 2 does not exist anywhere in this array. You might see a -1, but remember, we're not returning the element, we're returning the index. So this -1 is really at index 0, so it's irrelevant. And since the target 2 is not in this array at all, we're going to return -1 because there is no index containing the target. So explanation says 2 does not exist in nums, so we're going to return -1. So, all right, y'all. So now that we know what the question is asking, let's get into the fun part, the actual solution. Now, it's important to remember that when we're writing this solution, we need to write an algorithm that runs a big O of log and runtime, hence the name binary search. Hence the name binary search, right? So we can't just write a for loop that iterates through this and looks for target, because that would be big O of n log and big O of n runtime. We want to use big O of log n runtime. So that is going to require us to use a binary search. Now, it's not that difficult, y'all. Don't get too worried about it, thinking it's going to be way harder than a for loop. It's pretty simple. So let's get started and let's start building our binary search. So the first thing we need to do is we need to initialize 2 pointers for the binary search. So we could call one, we could declare a variable called left. We could set that equal to 0. Or we could declare another variable called right, and we could set that to nums.count -1, just like that. Now we need to continue searching while the left pointer is less than or equal to the right pointer. So in order to do that, we're going to say while left is less than or equal to right, we're going to open up the brackets. Boom. Now we need to calculate the middle index of the current search range. So in order to do that, all we have to do is we can say let mid equal, open up the parentheses, left plus right, and then come outside the parentheses and divide that by 2. And what that is going to do is it's going to find our middle index, it's going to find our middle index, which is going to shrink the search range for us. So now that we found the middle index, we can either search this side or we can search this side, or if the middle index happened to be target, which is not in this example, but if it did, then we would just return the target. So first thing we need to do is find the middle index. After we find the middle index, we can say if the middle element is equal to target, then we could just return its index. So we could say if nums square bracket mid is equal sign target, then we open up the brackets and we could just say return mid. Boom. Now if it's not equal to target, then that means we need to keep searching and we need to continuously shrink our search range. So in order to do that, if the target is greater than the middle element, we'll search the right half. So we can say if nums square bracket mid is, less than target. If num square bracket mid is less than target, sorry about that, open up the bracket, then we can say left equals mid plus 1. Then we come right here, we can say else if the target is smaller than the mid, then we need to search its left half. So we could say else if num square bracket mid is greater than target, boom, we open up the brackets and we can say right equals mid minus 1, just like that. And now if we go through all of this and we still haven't found the target, then we could just come right here and we could say return -1. So once again, if this completes without finding the target, then we'll return -1. So let's go ahead and give it a run. Make sure it runs properly, y'all. Look at that, y'all. It's accepted. So let's go ahead and submit it. Make sure it stays accepted, y'all. Once again, this is a binary search question. This is a very basic binary search question. So I hope y'all are paying attention because binary search is going to be important as you continue down our LeetCode journey, or as we continue down our LeetCode journey. And look at that, y'all. The time is, that's just terrible, but we'll get the time complexity up as we continue down our LeetCode journey. Right now, it's 4 milliseconds, beats 1.85% of users with Swift. Like I said, this is a very basic implementation of a binary search, but this is what we need to know. You absolutely need to understand how to write a binary search and what a binary search is doing if you want to be the best programmer you can be, or the best LeetCoder you can be, or the best competitive programmer you can be, y'all. Binary search is very basic fundamentals that have to be understood. So this is a very basic binary search. It's how it works. Read it, learn it, love it. Make sure you understand what's going on, y'all. And with that being said, y'all, get one more look at the code. That's the top half, bottom half. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.